powder.
You know who's a great guy?
Hey. Let's pay attention.
Ray Romano.
Alan.
It's smoking.
Videotape.
It's smoking?
No. I thought it was at first. Wait, is it?
No, it's not.
Should be. So?
Yay. Correct grammar, Matthew. Matthew.
Okay, remember, the bottom of the thistle tube must be submerged. So we create a
Sealed
system
environment.
for that existence. You have only one exit for the gas that's generated to come out through the right angle bend and through our tubing. Now I'm going to add some acid down the thistle tube. I'm going to let the first few bubbles escape. They may contain some oxygen or air.
What kind of acid?
Hydrochloric. I'm using 6 molar
Alright, you put 6 molar.
HCl. I'm just gonna throw in
LSD
some.
acid.
See what happens. Okay. There's some gas that's been released. I'm now going to
like alcohol?
put this in here. Can you see the rubber tubing?
Yep.
6 molar.
Yeah.
Keep an eye on that. Let's add a little more acid.
You just laugh at bubbles, Ryan.
I was like,
What's it supposed to do?
shape.
Yeah, I can't see anything. Why are you laughing at
It's
bubbles?
funny.
That's so cool.
Wait, there's water escaping.
The pressure's changing, so it's pushing out the water from the bottom. That sounded smart, didn't it?
That's what Dan said.
Almost.
Almost? It's conversation
Yeah,
going
forum.
on.
There's no forum.
Yes, there is. There's no...
You didn't put it up yet.
Oh yeah, but... whatever. I just wrote it.
I think there's some kind of air going into the gas
Regular air.
bottle that's not the sample. Because the things inside are moving up and down.
Yeah, a lot of activity there, huh?
Yeah.
Where?
What? I don't know, I can't see anything.
Wait, so that would be crazy though. So if that, what's in the pneumatic trough, is making air go into the snapper bottle.
Nothing's happening. There's gonna be so many jump cuts. I paused it like 10 times in a row. Oh!
Sound.
No, he
Alright, I'll put my head down.
She talks again.
I recorded open. Can you hear me? Why are you recording this if it's going wrong?
Like absolutely nothing is happening.
It's okay.
You should
Yeah, a
tell
lot
him
is
everything's
happening, you
wrong.
noticed.
Yeah.
You do have, if you want to come down and take a look.
Oh, you have some kind of bubble.
I don't see bubbles.
It's because of the zinc and the hydrochloric acid mixed together. Does that have anything to do with this? No, seriously.
Bit, folks. Here while you're here.
It's okay.
While you're here.
What? It's gonna get caught in the thistle tube. You just escaped some.
What secures that accident? There's like nothing.
Yeah, I was like, are you serious?
Our class is done.
There we go.
Is that it?
Yeah.
We made like a paragraph, a single paragraph all week.
Like stupid things.
What's wrong with Miss Kier, by the way?
And don't go on
What's the zinc with carrier?
What's wrong?
What's the zinc releasing?
Can we figure that out?
Is it releasing any sort of oxygen?
Exactly.
Because I'm done doing like fucking like French 1 word.
Oh,
Like the only thing here where like I don't know what she's gonna do with the funds.
And then like we have that obnoxious substitute.
Come on,
You ate her?
It's so annoying. She's like, this is not a paragraph.
It's like when it's like when Dan used to have those
She
conversations.
thought.
and he's just like, trying to get something out of Dan, and then he's like,
I think.
Yeah, it was like 5 sentences each, count them.
and Christy's just like 30 seconds.
She doesn't A paragraph can even be a sentence. It can be a sentence.
Yeah, you must be able to tell me that up here after
But it has to express.
Even on top of the line.
It can't be a run-on.
Blonde hair.
What'd you put in there, number
26. That's probably.
It's, zinc.
Oh, zinc.
It's rising up.
There we go, now we got it. That's where
What?
Because of me.
No, depends the way how you do it. Semicolons, commas.
Is that pushing up fluid?
Is that right?
No. Oh. That wasn't me, I swear.
No, it's not. It wasn't you. It probably was you. Is it? Why
There's
isn't
no
it
more.
going again through there?
Oh, the water's rising again.
You notice? Isn't that
It's
cool?
falling and rising.
Why isn't it going up through there though?
No, kidding.
Crap, you can't see because of this,
I'm not going
Okay, we can use that as gas laws. Let's explain. Alright, folks. Folksies, if you'll take notice, there's a very fascinating thing going on here.
I ate.
Alex.
Right angle bend, not the thistle tube. The right angle bend
Why
because,
can't it escape up the
because the bottom of the thistle tube is submerged in the water. So the gas can't escape because the water plugs it. Very important observation.
Say that one more time. No, do it again.
The gas that's being generated can only escape through the right angle bend because the bottom of the thistle tube has to be submerged in the water. And it's plugged by the water. Now Amira noticed that through this reaction, the water in the thistle tube is rising. It's approximately right here where my pointer is, and it drops down. It's rising here, and then drops down. It rises to here, and then drops down. In conjunction with the release of a gas bubble in this container.
I didn't notice that. I didn't notice that.
Oh, this is beautiful. Watch. It's up here. Drops bubble. Water levels rising up. Drops bubble. Because this is all pneumatics. Watch what's happening.
What would happen if
We
you-
whoa. Watch what's happening. We got pretty much a sealed system. Gas is being produced in the closed system. As the gas is being produced in here, it's trying to escape through this tube, but it's also building up pressure. When the pressure builds up in this bottom bottle, it puts pressure against the water and forces it up the thistle tube to a certain height, which is in relation to the air pressure coming down through the tube. So when it gets to this maximum height today, which might be different tomorrow and be different from last week, it can only rise to a certain height whereby the air pressure exceeds it and forces it down. Because there's a pressure system. There's the pressure of the water going up the tube. There's also the pressure of the gas escaping through this tube and making its way all the way through here, and whichever system succeeds first, releases a bubble, boom, this other one fails and drops down. You got two pressure systems. You got the pressure pushing this way, you got the pressure pushing down this way, and at this moment of height, you're at equilibrium. Right there, equilibrium. And then the gas is able to escape through this bottle. This water pressure pushing down is acting against this air pressure. It is fascinating.
Why is that remaining a constant?
Because this gas escapes. that bottle.
Oh, it's escaping it.
Yeah, the gas is going out through here, and it found, look, I'll get over here, because the purpose of any gas is to escape its system. And so it found an opportunity to get out through here, and consequently there's a reduction in pressure for a moment, and that air pressure pushed that water level down.
So what's happening to the water that was once active on that?
Well, now pressure is building up here and pushing the water level out,
So it's rising in the hole.
rising in the hole and going out my overflow tube.
Because when by the air pressure exceeds it and forces
The air pressure in here is going to exceed the water pressure and force the water down and out.
How long will it take to empty that bottle?
Well, we put in a certain number of grams of this. If we, well, and then I put a little chunk of it, just to speed it up, it will, if I put in more zinc and had a higher concentration of acid, then my reaction would proceed more quickly. Which we did in another class where we had it done in about 7 minutes. But the quality of my gas over here is not very good.
What would happen if you blew into the thistle tube?
If I what?
Blew into the thistle tube.
We could do that.
Do it, Alex, do it.
There was acid on it, Ryan.
I'll just push down against that gas, against that pressure right there.
Uh-huh.
I'll just push it down.
Forgot about the
force
hydrochloric acid.
more gas down it.
I forgot about the hydrochloric acid.
So if you're putting your hand over there, isn't that resisting the pressure that's going over your hand?
Yeah, but he's
So it would go
he's
higher?
creating pressure by doing that.
Oh, are you?
It's the same effect as blowing.
Plunging.
Oh, right,
It's
because
like
the air-
plunging your clogged
You're
sink.
bending the tube too.
Genius, but it's been around for at least 200 years. And you're Roosevelt Park kids living in high technology society. Which is why I say this stuff is on SAT exams, and many students have not been introduced to it, and it's a basic gas law water pressure system.
ACT.
What's the point of it? Like,
Oh my God.
other than capturing gas, what is the point?
Ah, that's what it is. It's capturing gas. How else would you capture gas?
But I mean, what would you use that gas
I
for?
would.
What?
What would you use the gas for?
Other experiments.
Oh, okay.
You want to? What gas are we making?
Oxygen.
Really?
H2?
Really?
Oh,
I
H.
said
Really?
oxygen. You said really.
Really?
O2.
Ryan.
And then I said hydrogen. You said really.
Ryan.
Testing you.
What?
What are my components in the beaker or the bottle?
Water, zinc, and HCl.
Okay.
Yeah.
Zinc reacts with chloride, leaving H2.
Water.
And that, oh.
What is your basic reaction of an active metal in an acid?
I don't know.
That is by law.
Oh wait, hydrogen comes off. Yeah.
So now when you say what is the purpose of this other than just collecting a gas, you're rephrasing it to appreciate that I can set up a reaction in a reaction container, generate a specific gas, and collect a pure bottle of that gas, or a bottle of the pure
How do you
gas.
trap it without it
How do you
getting out
trap
then?
the gas once all that water?
Yeah, without it getting out.
Without some escape.
That's why every Snapple bottle comes with
Yeah,
a
but how do you prevent it
stopper.
from
Cap it underwater.